Hey guys, welcome to my first ever Godot tutorial. Today I'll be teaching you my setup for how I make things like cars, tanks using the vehicle node. So I have a blank project right here. The only thing that I've added is my vehicles folder, which contains the vehicle I made in Blender along with its materials, but I'll be showing you that later on. So first things first, let's make a test area to work with. So click on the 3D scene up here, rename the spatial node to world, add a static body as the child, which is going to be our floor. So after that, create a collision shape for it. It's going to be a box shape, X by 50 and Z by 50. After that, you can see we have a big area to work with. We're just going to add a mesh to that so we can see exactly what we're working with, like that. And then finally change the size to 100 by 100 and add a new material by clicking on the materials tab and new spatial material. Click on this, albedo, and click and drag the icon.png. So as you can see, it's a bit ugly, but it is what it is. Click on the UV1, click on triplanar, and it's going to tile it along the mesh so we can see things like when the car is moving about, how fast we're going, direction we're going, yeah, just stuff like that. So that's pretty much done. We're just going to save this as our world.tscn. There we go. And now we're ready to start working with our vehicle. So if I open up the model that I made in Blender, new inherited, as you can see, it looks a bit complicated, but it's not actually that complicated. We have a few meshes to work with. We have our body, we have our turret, which is this thing right here, excluding the gun, and then we have our gun, which is this thing here, and then we have our four wheels, front left, back right, back left, front right. Yeah, so that's pretty much it. What we're going to be doing is we're just going to be changing our spatial node into a vehicle body node, just like that. And then it says here that we need to have a collision shape. So click on the body, click on mesh, create single convex collision sibling, drag this up, make the body a child, and then rename this to body, just like that. So we're going to be doing the same thing to the turret as well. Mesh, single convex collision, and yeah, drag it in like that, rename this to turret. And then finally what we're going to be doing is we're going to be dragging the gun here, because what that's going to do basically is once this starts rotating, it's going to rotate along with the turret as well, which is exactly what we want. So this is the part that's a bit tedious, but it is what it is. As you can see, we have our four wheels here. What we're going to be doing is we're going to be creating the wheel as a child, because what we want is we want the vehicle wheel to be created in the origin point of the mesh itself, but we want it to be the parent. So this is the tedious part. We're going to drag this out, drag it back in, and then rename this to the appropriate name like that. So I'm doing the same thing for everything else as well. Add child node, vehicle wheel, drag it out, drag it in, rename it, BR. Same thing with this as well. Add child node, vehicle wheel, drag it out, drag it in, wheel, BL. And then finally the same thing for this, like that, drag it out, drag it in, rename it, wheel, FR, front right. So that's pretty much done in terms of setting up the vehicle itself. Now we'll be going over the properties of each thing on the wheel node itself. So we're just going to go to our front left wheel. There are a bunch of things that you can look at. You can actually hover over it. So it kind of briefly explains what each thing does. But for simplicity's sake, we're just going to be concerned with these three tabs right here. So vehicle body motion, because it's the front wheel, it's going to be our steering wheel. So we check steering like that, wheel. And then afterwards, as you can see here, we have our radius, rest length, and friction slip. So the radius is perfect right now. Basically, it kind of goes outside the wheel, which is exactly what we want. But if I change the value for like 1, as you can see, it expands like this for things like big wheels, small wheels. Just kind of scale it appropriately to whatever size of wheel mesh that you got. So 0.5 works for me. Great. Rest length is basically, if you can see this spring right here, it's the distance of which the wheel travels from its original position. So as you can see, if I change it to 1, the spring elongates. So this is going to be moving a longer distance from its original point, which isn't what I want. I actually want it to be exactly where it is. So 0.15 works for me. And finally, friction slip. So friction slip is basically if you want your cars to drift, or if you want to simulate things like wear and tear of the tires. Um, as you can see in the description, it says 0 means no grip, 1 is normal grip. So I'm not quite sure why it starts at 10.5, but let's just change it to 1, just for the sake of it being normal grip. And finally, suspension. Travel is basically the distance of which it's going to travel up and down from its center point. I don't want it to travel too far, so I change it to 0.1. And finally, stiffness is like the bounciness of the suspension itself. I like setting mine to 50. As you can see, if you read the description, um, 50, 100, 200, depending on the type of car it is. But for simplicity's sake, I'll just put it as 50 for the time being. So that's that for the front left wheel. For the back right wheel, it's going to be the same process as well. The only difference is we're going to be changing the vehicle body motion to traction, because basically it's going to be the thing that's going to be pushing the car forward. Wheel, perfect, everything's good. The only difference that I'm going to put is the friction slip. I'm going to be changing it to 0.7, because like I said before, I want the back wheels to be slightly lower than the front wheels so I can start drifting my car a little bit. And suspension changes to 0.1 and 50, and then do the same thing for the other wheels as well. So I go here, because this is a back wheel, traction, yep, friction slip 0.7, suspension 0.1, 50, and finally front right wheel, it's going to be a steering wheel, friction slip 1, suspension 0.1, 50, just like that. So that's it pretty much in terms of setting up your wheels. The only thing we need to do right now is we're going to be setting a camera for the car to work with. But there's one thing I want to mention as well. If you click on the original vehicle body node, you'll notice that the origin point is slightly, well, it's in the center, right? But this isn't exactly what we want. The lower the origin point is, the less likely it is to flip over. So what we want to do is just click on everything here, click on the snap, and then bring it up by 1. So that way, when we click on the vehicle body node, you'll see that it's just on the ground like this, which is exactly what we want. Yeah. So save this, save it as Humber, because that's what it is. And we're just going to be adding a camera, because this is the thing we're going to be working with, right? So let's just add a camera. The way that I set up my camera, at least, is I make a spring arm first, and I'll just drag it up so you can see what it looks like. What a spring arm does, if you see that line, basically whatever is attached here will be kind of moving along that line, and whatever collision occurs is going to be moving along that line accordingly. So if I attach a camera onto it, which I'm going to do anyway, clip camera, just like that. If I click on this thing right here to test the scene, as you can see, the camera moved back along the spring arm as opposed to being just here. So what I don't want it doing is I don't want it coming in contact with the vehicle itself. So what I tend to do is I tend to change the spring arm collision mask to being on layer 2. And then I'll be adding a code later on to the spring arm just to show you how to avoid this entirely. So save this, go back to your world, and import your TSCN. Make sure that it's not on the floor, take off snap, up, and then set your main scene as your world.tscn. Yeah, so as you can see, the vehicle is now in the world. Everything is working fine, beautiful. So now I'm going to start adding some code onto the vehicle itself. But before I forget, we're actually just going to change one thing on the vehicle body. So click on the vehicle body, and as you can see here, we have the mass and the weight. So usually for most cars, they're 1600 kilograms because the weight is measured in kilograms. We're just going to change that to 200 just because it's an armored car and it's going to be heavy, right? So yeah, that's pretty much it. So what we're going to do now is we're going to go to project settings, and we're just going to set a few key bindings. So W, A, S, D, followed by a space, and then ESD for escape. So if we add it by clicking on the plus sign, just like that, now we can start adding the code onto the vehicle body itself. So right click and go onto attach script, humber.gd, and let's set a few variables. So the variables that we're going to be setting is horsepower, which I'm going to be setting to 200 equals 200. Var acceleration speed is going to equal 20. Var steer angle. So what this is going to be is basically going to be the max angle of which our wheel can rotate. We're going to be using a function called deg to rag, which is basically degrees to radians. So usually when it comes to rotations, it's calculated in radians. So to make things simpler, we use this function to convert a degree into a radian. And after that, var steer speed is equal to 3, and then var brake power is equal to 40, var brake speed is equal to 40. So basically what's going to happen is once we click on the brake button, it's just going to lerp straight to that as fast as possible. And we're just going to add the function physics process. So usually with rigid bodies, you'd be using integrate forces, but for some reason I found a lot better success using physics process instead, at least for this particular instance. So what we're going to be doing is setting a few input variables. So var throttle input or throt input is equal to negative input dot get action strength, W plus input dot get action strength S, and then engine force. So what the engine force is, if we go back to the vehicle body node, it basically determines if you're going forward or back. So negative values meaning along the negative axis, which is basically forward, and then positive values meaning you're going backwards. So if we go back to the script, we're just going to be lerping, linear interpolating our engine force to our throt input times our horsepower. So what this means, if you're pressing W, so it's going to be a negative value, it's going to be -1 times horsepower, and it's just going to be lerping to a negative value, -200, and moving you forward at the speed of XL speed times delta. And yeah, the second one's going to be our steering. Var steer input, var steer input is equal to negative dot input get action strength. This one's a bit different though, because when it comes to steering, it's kind of inverted. So D is going to be our left. You'll see when I stop playing the project itself. Dot input get action strength. A, sweet. And then steering is equal to lerp angle. So basically linear interpolating the angle. Steering, steer input times your steer angle, your max steer angle, and then steer speed times delta. And finally, our last variable that we're going to be inputting is our brake input, which is just going to be input.get action strength, space, because that is our brake for now. And then brake is equal to lerp brake input times brake power brake speed times delta. So let's just put some comments so we know what each thing is. This is going to be our throttle, this is going to be our steering, and this is going to be our braking. In terms of coding, that's pretty much all you really need to move your vehicle around. If you want to change how fast the maximum speed it can go, if you want to change how fast it gets there, if for some reason you want to be able to turn your wheels in even greater or less value, you can adjust this and how fast it turns and the brake speed, etc. So let's just run the project so you can see what it looks like right now. So as you can see with my project, if I press W, which is forward, it moves forward. If I press A, it turns left. If I press D, it turns right. If I press space, it brakes. And then if I press S, it reverses, just like that. So what we want to do now is just be able to move the camera. So I'm just going to be adding some coding to that so you can see what it looks like from the side, front, and just get a better view of what's going on. So let's go to our spring arm over here. What I'm going to do is I'm going to rename it to camera instead, and I'm going to attach a script, camera.gd, yeah, and function ready. So the two lines of code that we're going to add, input.setMouseMode to input.mouseModeCaptured, as well as clip camera.addException, get parent. So like I said before, what I don't want my camera doing is I don't want it getting stuck behind the model itself. So this line of code fixes that, as well as making our mouse invisible up here, so that way it won't get in the way of, well, immersion, I guess. Function input event. So we want to be able to toggle between these two modes as well. So let's just add a few lines of code for that. Toggle mouse mode. If input dot is action just pressed, ESC. If input dot get mouse mode is equal to input mouse mode captured, input dot set mouse mode, input mouse mode visible, else input dot set mouse mode, mouse mode captured. What this means, if I press the escape key, it checks if I'm currently in the mouse mode captured. If I am, set my mouse to visible, otherwise set it to captured. Done. Next one. Move camera. Rotation. Actually, so the very first thing you want to do is you want to check if the mouse mode is currently captured. So if get mouse mode is equal to input.mouseMode captured, then if event is input event mouse motion, rotation degrees.x equals clamp, rotation degrees.x minus event dot relative dot y times 0.1 negative 45 rotation degrees dot y minus equals event dot relative dot x times 0.1. So this line of code here, basically it clamps the up and down rotation of the camera to 45 degrees. That way we don't flip our camera entirely. And this one is just basically turn the camera around. So let's look at the project right now and see how it looks like. So as you can see now, if we move around the camera, everything works as intended. Up and down is locked at a 45-degree angle. The camera doesn't get stuck behind the vehicle, but it still collides with the floor, which is exactly what we want. If we press the escape key, we can toggle between mouse modes. So for example, you can have menus and stuff like that. If you want to click on without it affecting the camera, press escape again, go back to moving the camera, and then controls still work as usual. So you can move around, yeah, brake, reverse, and that's pretty much it, yeah. So I'll be adding some other stuff as well, how to move the turret, how to shoot the gun, stuff like drifting, adding particle effects. If you guys want me to look into anything in particular, I'll try my best to research and make it into a tutorial for the next video. Otherwise, yeah, second part will be in the part 2, and I'll get it done. If you enjoyed what you watched, feel free to subscribe and have a great day.